Hello everyone, this is Stan. In this video I'm going to talk a little bit about winterizing this OM Tech 60 watt CO2 laser and this CW3000 chiller. And I want to give credit where credit is due. I saw this idea from Chad's Custom Creations, and I will put a link to his video down below so everyone can check that out as well. But in his video, he's using an aquarium heater to heat the water in his chiller, and then circulating that with a small pump, which I'm doing as well. But anyway, but I did made a few little changes for me. One of the things that he mentioned in his video is that he used a 50 watt aquarium heater, and he wished he had have gone up just a little bit more in wattage to 100 watt. I went with this 200 watt Fluval heater. That worked well for me. Plus I wanted a little bit more length on the heater to reach further down into the water tank. One of the things that I did differently when mounting mine, instead of putting it inside of the fill port on the top of the chiller, I opted to drill another hole through this case and then through the top of the tank, where I mounted and cemented this to it. I'll pull the cover off so you can take a look at that. Okay, so what I did was, as I mentioned, is I drilled a small lead drill, 1/8 inch drill, through the top of this case and into the top of the tank. Just a small drill to be careful not to get any debris in the tank. But and then after I did that, I followed that up with a larger bit. I used a Forstner type bit to drill into the top of this a little bit, to basically provide an outline and to cut into the top of this a little bit, and then follow that up with using a utility knife to cut into the top of the tank. And then I inserted a tool, a pick tool, inside of the hole so that I would prevent the piece from falling into the tank. And by doing it that way, you prevent getting any material down in the tank and having to deal with, getting it out, emptying your tank and all of that. And what I did also, after I cut the hole in the top of this, I 3D printed this ring and cemented it to the top so that it would look, a little more finished. I also originally purchased a flow gauge. This is very similar to what Chad purchased, but when I got it, I wasn't real thrilled about the hole size in it, and I could have sent it back, but I didn't. But what I thought I would try is to 3D print one. So what I did was 3D print the housing and the wheel inside, and then I cut the clear acrylic pieces with the laser. I purchased the barb fittings, and when I 3D printed the body of this, it was just a round hole, and then I ran a 1/4 inch NPT pipe tap into that and threaded it on each side. And then of course made this little bracket here so that I could bolt it to the top of the chiller. I cemented the pieces together with some of this E6000 cement. I use this a lot, and works really well. Okay, here's a little update. When I mounted the original flow indicator, originally in the design I had it so that you could bolt it to the side of the case with 2 3mm screws, and that was fine. But if you get any air bubbles in the lines, the air bubbles will get trapped in the top of these vanes, and the only way to really get them out is to be able to tip this upward to try to, to get the air bubbles out of it. That's kind of difficult to do when you bolt this to a chiller cabinet and you can't flip the cabinet over. So what I ended up doing was redesigning this case so that I could flip it up like this and get the air bubbles out of it. And you can see there's some air bubbles in it right now. So I can actually turn this on. And then I can flip this up like that to help push the air bubbles out. But while it's turning, it actually doesn't want to work right. Let me turn it back off. All right, there we go. So let me flip this up. Get the air bubbles in there, actually in the line right there, and I'll turn it back on. All right, let me turn it back on. And that'll push that air bubble right on through the line. Anyway, that's a little bit better. Plus, another thing that I discovered, the original design, the vane that I had in here, I had it at 2 millimeters thick, and when I'm using the small pump to circulate the water to keep it warm when I'm not running the chiller, sometimes this vane would not rotate. It would rotate fine when I actually filmed it, but after a while when I came back out, it was stopped. It wasn't rotating. The water was still moving through it because it does not push a high volume of water through the circuit, but I still wanted this to turn, so I redesigned it so that this would be much easier to rotate, much lighter. So let's try that out and see if that works. Okay, so now I have the smaller pump running, and I think that will work just fine. That looks like that rotates pretty easily. Like I said, the water was passing through the circuit, but I wanted to still see this rotate. So I think redesigning this vane helped with that. It basically cut the weight of this in half. So anyway, just wanted to pass that along. I'll have a link to these files down below for anyone that's interested in making one of these for themselves. If not, they're all over Amazon, but I'm one of these guys, why buy it if you can make it? Anyway, hope that helps. Here's the pump that I purchased. I'll leave a link down below. I picked this up from Amazon. It had 3/8 barb, hose barb fittings, and they were just about the right size. Hoses were a little snug getting in them on, but that worked out perfectly for me. Something else that I did a bit differently is I wanted to monitor the temperature of this just to make sure that, it's doing its job, it's keeping the water to temperature. So I wanted a little bit of an insurance policy on that. So what I did was purchase this wireless temperature sensor. And what that's doing, of course, is, as the name implies, it is monitoring the temperature of the water passing through the tube. And I've got it taped around the tube right there. And just for comparison, I've temporarily taped a temperature probe for my meter just to see how close they all are. I know that right now, because I've got the lid off, I unhooked the water heater. So it's running about 13 degrees Celsius on that. And that's pretty close to what the meter is reading. I'll leave a link down below for the wireless temperature sensor for anyone interested in that. It is a bit pricey. The one I purchased was about $99. You can find them cheaper, I'm sure, but I like that one, so I went ahead and purchased that. And then something else that I did for this was to 3D print a mount for it, so I can take this out of this cradle if I need to. It's a convenient way to hold it. Something else I like about this is that it will send me an alarm if the temperature drops below or rises above a certain temperature that I have set in the app. I like that. So that way I can check in from time to time, particularly on those really cold nights, just to see how it's doing, see if it's keeping up. This will be my first winter trying this out. We're into November now, so we've only had a couple of cold nights, but it hasn't gotten down cold enough in here to freeze yet. One of the other things that I think people would like to know, and I've seen on Chad's Custom Creations, people were concerned about having this pump in line with the water lines, and will it work if you leave it in place? You know, will the main pump work? Well, right now I'm running the main pump and the water is moving quite well. There's no problem at all with that. The pump doesn't have to pump as much as the chiller pump does, but it does have to move the water well enough to keep the warm water passing through the entire circuit. What I'll do now is I'll turn this off and turn the little pump on so that you can see the difference in flow between this and the smaller pump. Okay, so here you go. This is the smaller pump running. You can probably hear it. I don't have any rubber or anything like that in between here, so it tends to be a little bit more noisy mounted to that sheet metal. It doesn't pump nearly as much water as the pump inside the chiller, but that's okay. To me, this flow is adequate. It will circulate the water just fine with that. So that's it for this video. I hope you guys find this, helpful, useful. If you think it's worthwhile, if you don't mind, like and subscribe. I appreciate it. Till next time.